Alright, hello everyone. This is part 2 of the Infinite Geometric Series practice problems. So let's go over the advanced problems. Um, I've worked through the rest of the problems in this worksheet in the previous video, in the part 1 of this. And now we're going to be finishing it off with these two problems. Okay, so let's read through this. It says the sum of an infinite geometric series is 64. If the second term is 16, find the first term and the common ratio. Okay, so let's just write down some of the stuff that we know. We know that the sum of the infinite geometric series is 64. So if we're using this formula, right, S infinity is 64. So I'll write A over 1 minus R is 64, right? And let's see, what else do we know? It says if the second term is 16. So the second term is 16. Now in a geometric series, the first term is our A term. The second term would be A times R, right? We could also find that using this formula. So n minus 1. For the second term, when n is 2, we get 2 minus 1, which is 1, and so we get AR. Okay, so, but I think this method is easier. The first term in a geometric series is A, and the second term is AR. So they're telling us that AR is equal to 16. Okay, notice here that we have two variables, right? We don't know A, we don't know R. Okay, we have two variables, but also we have two equations. So we should be able to solve for both A and R. How can we do this? We're going to use our good old method of substitution. So what I'll do is I'll take this one, and you either have to solve for A or solve for R. I think I will solve for A. So you know that A is going to be, if we divide both sides by R, 16 over R. Then I'm going to take this A and plug it into the top equation. And so we're going to get 16 over R all over 1 minus R. Maybe I'll write it here. 16 over R all over 1 minus R is equal to 64. I'll multiply both sides by 1 minus R. Okay, so let's fix this arrow. Multiply both sides by 1 minus R. 1 minus R here as well. Okay, so the 1 minus R here cancels out, and we end up getting 16 over R is equal to 64 times 1 minus R. Okay, I'll multiply both sides by R here. Okay, and we will get, so I'll write it here, we will get that the R's cancel, and so we have 16 is equal to 64R times 1 minus R, like that. Okay, so I'm going to erase all of this now, and yeah, let's erase all of this and solve the equation. Okay, so our equation we want to solve is 16 is equal to 64R times 1 minus R. Okay, so let's solve this. I'm going to distribute in the R. So maybe first we should simplify the 16 and the 64. So I'll divide both sides of this equation by 16. So 64 divided by 16 is going to be 4. So we get 1 is equal to 4R times 1 minus R. Now I'll distribute this guy in, and that's going to give us 1 is equal to 4R minus 4r squared. Okay, and let's go ahead and rearrange everything. So I'm going to move everything to one side. So if I move everything to one side, we get, I'll subtract 1 from both sides here, right? We're going to get 0 is equal to 4r minus 4r squared minus 1. I will also rearrange things so that everything is ordered from the highest power to the lowest power. So I'll write negative 4r squared plus 4r minus 1 equals to 0. I will also multiply both sides by negative 1. So let's multiply both sides by negative 1. Okay, so that's going to get distributed in. And when we do that, we're going to get 4r squared minus 4r plus 1 equals to 0. Okay, so let's erase this and solve this equation now. All right, so here we go. So this is what we want to solve. We want to solve this for r. We're going to notice that this is a quadratic, right? It's r squared. And the way we solve quadratics always is by factoring. Factoring if possible. If not, we can use something like the quadratic formula. Okay, so to factor this, we're going to look at the factors of 4 and 1. So 4 can be broken up into 2 and 2, and 1 can be broken up into negative 1 and 1. And we can see that if you guys aren't familiar with this factoring technique, use whichever one you're comfortable with. I will also do a video on factoring at some point and go over all of these techniques. But anyways, we can see that if we can break 4 down into 2 and 2, and 1 into negative 1 and 1, and the product of these are negative 2 and negative 2. The sum of this is the middle term, which means the factors here will be 2r minus 1 and 2r minus 1 equals to 0. Again, if you guys aren't comfortable with how I did it here, you can use whatever method you're familiar with, or watch a future video that I'll do on factoring. Might even be posted by the time you're watching this. Okay, so whenever two things multiply, two brackets, two numbers get multiplied by one another to give us 0, that means either the first number, 2r minus 1, so either the first set of brackets is equal to 0, or the second set of brackets is equal to 0. In this case, they're both the same, so it doesn't really matter. And if we solve this for r, we get that r is 1/2. Okay, how do we solve? Let's go over the solving steps. So it's 2r minus 1 equals to 0. Add 1 to both sides, and that gives us 2r equals to 1. Divide both sides by 2. We get r equals to 1/2. Okay, so like this, r equals to 1/2. And we're going to get exactly the same solution from the bottom one. So our only solution here is that r is 1/2. And the question was to find the first term and the common ratio. So here's the common ratio. How do we find the first term? Well, we can plug in r into either one of these equations and solve for a, because that's the first term, right? This equation seems the easiest, so I'm going to use that. A is what we're looking for. R is 1/2, and that's equal to 16. We can multiply both sides by 2 to get that. A, right, because 2 and 1/2 cancel, a is equal to 32. Okay, so the first term is 32 and the common ratio is 1/2. All right, let's have a look at the last problem. So let's see. It says in an infinite geometric series, the sum of the first 4 terms is 80, and the sum to infinity is 100. Find the common ratio and the first term. Okay, let's see. So we're just going to write down equations again. We'll write down everything we know in terms of an equation. So the sum of the first 4 terms, we know how to do that, right? The sum of the first n terms is a times 1 minus r to the n all over 1 minus r. So that means the sum of the first 4 terms will be S4 a 1 minus r to the 4 all over 1 minus 4. Sorry, 1 minus r. And so they tell us the sum is 80. So S4 is 80. I'll write it on this side. Okay, we also can use our infinite sum formula. We know that the sum of the terms, the infinite series, is 100. So we can write that a over 1 minus r is 100. Okay, so now I'm going to erase these and just put these guys to the side. Okay, how many unknowns do we have? Well, we don't know a, we don't know r. So there's 2 unknowns there. And how many equations we have? We have 2 equations. So 2 equations and 2 unknowns, we should be able to solve this. We'll use substitution again. I'll solve for a in the bottom equation. And the way we can do that is by multiplying by 1 minus r on both sides. So we get a, right? 1 minus r cancels out on top and bottom. We get a is equal to 100 times 1 minus r. And by the way, I forgot to mention this earlier, but the fact that they tell us that the sum, the infinite sum, is 100 means that this is convergent, right? It means that r is between -1 and 1. So we should expect r to come out to a number between -1 and 1. Okay. Anyway, so we found a. Now we're going to plug it in here. So let's go ahead and do that. So a is 100, 1 minus r, 1 minus r to the 4 all over 1 minus r equals to 80. We're going to notice 1 minus r and 1 minus r cancels. Okay, so then we'll get 100 times 1 minus r to the 4 is equal to 80. I'll divide both sides by 80. So that's going to give me 1 minus r to the 4 is equal to 80 over 100. Sorry, I meant to say I'll divide both sides by 100 to get 80 over 100. 80 over 100 simplifies to 8 over 10 or 4 over 5. Okay. So now I can subtract 1 from both sides, right, to get rid of this one. So I'll get negative r to the 4 is equal to 4 over 5 minus 1. 1 is the same as 5 over 5. So negative r to the 4 is the same as 4 over 5 minus 5 over 5, which is negative 1 over 5. The negatives cancel, and so we get that r to the 4 is 1 over 5. To solve for r, we'll take the 4th root here. Okay, so the 4th root. Okay, and what does this give us? This gives us that r is equal to the 4th root of 1 over 5. So this is our r value. Okay, so now there is one more thing that we need to add here. So technically, whenever we take the eventh root of something that's raised to the power of an even number, like taking the square root of x squared, or taking the fourth root of x to the 4 or r to the 4, we have to introduce a plus or minus here. So we have two solutions. If you look back at the original expression here, r to the 4 equals to 1/5. R can either be the positive fourth root of 1/5 or the negative fourth root of 1/5. Because if I take negative fourth root of 1/5 and I raise it to, so if that's r and I raise it to the power of 4, to the power of 4, the negative of course cancels, right? Because if I multiply this by itself 4 times, I'm going to get 4 negatives that are being multiplied by each other, and that's a positive. And so these guys go away and we get 1/5. So both of these work. Here's another example if that didn't make sense. If we have x squared is equal to 25 and I square root both sides, x is equal to plus or minus 5. Why? Because, well, both 5 squared gives us 25, as well as negative 5 squared, which gives us 25. Okay, so that's why we need the plus or minus. So we have two possibilities for r, positive or negative. And we're going to just leave it in exact form like that. Okay, now for the calculation of the first term, the a term. I'm going to use this to calculate a. So we have two possibilities, right? One is when r, and both of these solutions that we'll come up with are correct. It's just two possible solutions. We can have two possible solutions for this problem. So when r is positive, fourth root of 1/5, a will be 100 times positive fourth root of 1/5 minus, 1 minus positive fourth root of 1/5. So that's going to be a. And I'll just leave it in exact form. And number 2, when r is negative fourth root of 1/5, a will be equal to 100 times 1 minus, and then r is negative. So the two negatives make it positive, and I can just write 1 plus fourth root of 1/5. And let's quickly get the decimal value for these, just so we have an idea of what these numbers are. Because remember, we were expecting r to be between -1 and 1, right? So let's see if that's the case. So the fourth root of 1/5, this guy will be 0.66874. And so, of course, this is the negative of that, so it'll be negative 0.66874. There's more decimal points, but I'll just leave it at that. Okay, and now we can find a. So let's calculate this a for the first case. So that's 100 times 1 minus the fourth root of 1 divided by 5. All right, so a will be roughly, these are all approximate, 33.12596. And down here we will get, let's see, so change this to a plus, and this will come out to 166.87403. Okay, so those are the two possible solutions. All right, that's the end of this worksheet. I hope you guys enjoyed those problems. If you have any questions about anything, please put it in the comment section and I'll do my best to get back to you guys. All right, I will see you guys in the next video.